So this is the first of the chemistry videos in section 1, which is the history of chemistry, the introduction of chemistry, modern chemistry, whatever you want to call it. Okay. I have a video here, but I have learned through trial and error that you can't hear the videos when you go there. So D2L will have a resource page for each chapter, and in that resource page will be a hyperlink to any of the videos that I have currently in my PowerPoint. So this one's about a 13-minute video that shows you the 10 most fascinating chemistry experiments to kind of show you what you can do. I won't make this one required. Some of them will be required viewing, but it's kind of cool to watch the 10 most fascinating experiments that they have. So why is it that vet tech, biology, plant science, EET are all majors that have to take this Principles of Chemistry class? Okay, and so I'm going to start out down here at the bottom of the page that shows you kind of a map of the sciences. And chemistry is often called the central science. So for veterinary technology, they don't really have on here, but they have medicine, which is closely, it's just the veterinary, it's just medicine of the animals. Biology, we even have a toxicology program. Food and science, nutrition, have to take this. Plant science or agriculture. The nanoscience, nanotechnology, but material sciences is why the EET majors have to take this class, even into computer sciences. So a lot of sciences are overlapped, but chemistry tends to provide a link to all of them. And in today's world, very seldom do you have an area or a project that is only focused on one science. Most science experiments now have multiple areas that you need to look at. So we study chemistry. Now, this class doesn't get quite as exciting because we need to give you a foundation, a basis of knowledge. So the reasons that we look at practical applications. Okay, so what are two big areas of research that's being done in chemistry right now? Well, pharmaceuticals will always be a big area. New drugs, new development, that type of thing. The other one is probably what you are watching this device on, or what you're watching this video on, devices. Okay, everything from the display of these devices to, more importantly, the batteries. Okay, in today's mobile world, we want batteries that last longer, take less time to charge, but don't catch on fire. We use chemistry to explain things that we see. And we link, like I said, chemistry links a lot of the sciences to other sciences. So chemistry, however, is a relatively new field. Okay, they started making products from natural materials. So they made pottery from clay, bread from grain, copper tools from copper, and ores. But it wasn't until the late 1700s, so we're talking basically just over 200 years, about 250 years actually, that chemistry has been a field. Now, compare that to biology and a lot of other sciences, they're much older fields. Okay, and in chemistry, we basically have two divisions. We have atoms, which is the smallest building block, and we have molecules. Okay, an atom is just one piece of everything else that you're going to make. So I have an atom here, and in this drawing, this is hydrogen. The structure happens to be called isobutane. And the black or gray are carbon atoms. So I can bind hydrogen to carbon, or I can bind carbon to carbon, and to make the structure. This this structure has 4 different carbons, and it has 3, 6, 9, 10 hydrogens on it. Okay, and then I can take these simple molecules and I can make more complex molecules from those. And so what I have down here is something called a polymer, which we'll introduce again later. But this is a polymer, and a polymer is simply a word for plastic. Okay, plastic is a very generic term. And if you look at this very carefully, if I draw this out just right, okay, you see that what I have drawn in this in this green box here is actually just one of these structures. And that's true. Now, I can't draw it exactly because of the fact that the way it's linked. but there's another one, okay? So a polymer is just typically a repeating set of molecules that are bound together, okay? And so this is an isobutane polymer here that's being put together into something. And polymer, like I said, is a very, very broad field. Plastics are polymers, okay? So we can have everything from a plastic that stops bullets, which is what Kevlar vests are, to plastic bags, which are easily to crumble, but they tear fairly easily, to devices that you can squeeze, but they don't break. All kinds of things make up the field of polymers, okay? So some modern examples of chemistry are liquid crystal displays. That's what you're watching this video on, whether it's a laptop or your cell phone. Probably even the monitors in the computer lab have liquid crystals displays. They're a series of molecules that align with electrical charge to give off color. Okay, and so this would be an example of one of those molecules. It's a fairly complex molecule, and by changing the different parts of this molecule, I get different colors in the display. Of course, DNA, discovered by Watson and Crick. These are all molecules that are lining the DNA. Penicillin, which is the oldest of these examples here. Penicillin is the structure down here, okay? And this is a picture of penicillin. And so this is the pharmaceutical name there. So this is video for